All right, 15.6 geometry applications. So the first thing we're going to be doing applying geometry to what we've been working on in class is the distance formula. The distance formula basically comes from the Pythagorean theorem. So you can see here we're going to find the distance between point A and point B. Well, the distance right here, if we could make a right triangle on a coordinate plane, the distance we're actually trying to find is our hypotenuse, or C, from the Pythagorean theorem. The two legs that you see here is just a given, or trying to graph it on a graph, would be our two legs, A and B. So the first thing that we would do with this is we would do A squared plus B squared equals C squared. And then in order to get C by itself, we would solve these and then take the square roots. So we would have the square root of A squared plus B squared is equal to our C term, or in this case, our distance. So we're going to write the distance formula, not from A and B, but from our actual coordinate points of x1, y1 and x2, y2 for our first point and our second point. So to find your distance, or D, we take the square root of, and our first one, A squared, is actually the x values subtracted from each other. So it would be x2 minus x1 quantity squared. That would be our A. And then our y values would be the distance from the y's. So plus y2 minus y1 quantity squared. And this will find us the distance between those 2 points without having to actually draw it on a coordinate plane. For example, our first problem, given the 2 points, -5, +1, and -2, -2. So we're going to find the distance between these 2 points. I'm going to just label this as x and y and x and y. Now, when you're actually talking about x1 and y1, x2 and y2, it's up to you what you want to label them as. I'm just going to say, since this is my first point, these are my first x and y, and these are my second x and y. But you can label them however you want. So I'm going to write this as distance equals the square root of, and I'm going to subtract my x values. -2 minus -5 squared plus -2 minus 1 quantity squared for our y values. Just using this formula and plugging those values in. Then we're going to simplify. Well, this is actually changing to a plus sign for minus a negative. So I have my distance equal to the square root of -2 plus 5 is +3, and -2 minus 1 is -3. Don't forget these are in parentheses, so +3 squared gives me 9, and -3 squared gives me 9. This equals the square root of 18. Now, if you were actually working a real-world problem, we could find that decimal amount and round it. But since we've been working with radicals in this lesson, we're going to simplify these as 9 times 2, our perfect square, or 3 square roots of 2. So there's our distance for our first problem. All right, here's the next one. Given the 2 ordered pairs, 2, -3, and 5, 1, I want you to pause the video and practice finding the distance on your own. Push play when you are ready to see the answer. All right, so you solve this problem hopefully by plugging in. You can use either x1, y1, x2, y2, or if you had flipped them around, you should get the same result in the end. So I had this as my first point and my second point, so I did 5 minus 2 squared plus 1 minus -3, which changed to a plus sign squared. which is 3 squared plus 4 squared, or 9 plus 16, 25, and the square root of 25 is actually perfect, and it came out evenly for our distance to be 5 between these 2 points. All right, moving on to the next section. The distance D between 2 points is given. Find the missing value. So for this problem, I'm going to give you the ordered pairs, -3, 2, and B, 2, given that the distance is equal to 10. So we know our answer, but we don't know one of the coordinate points, and we're going to find the missing value. So all I'm going to do is I'm going to plug all the values in that I know into the distance formula. So since D equals 10, so we put 10 equals the square root of, my first x value is the unknown, or my second one, I'm going to do b minus -3, or b plus 3 quantity squared. And my y values, 2 minus 2 quantity squared. All right, well, 2 minus 2 quantity squared, this is going to be 0. 0 squared is 0, so plus 0. This is actually going to be taken out of the problem. We don't need that part in this problem. So the first thing that I'm actually going to do with this problem is I have here 10 equals the square root of b plus 3 quantity squared. In order to get rid of a square root, we have already learned that you square both sides. So I have 10 squared, which is 100, equals b plus 3 quantity squared. All right, so the next thing I'm going to do is I'm going to notice, in order to get rid of the squared term, now that I don't have anything over here, I can take the square roots of both sides. So the square root of 100 could be 10, or it could be -10. Since we're actually solving, I'm going to use both solutions. Square root and squared cancel each other off, and I have b plus 3. Solving for b, I'm going to subtract 3 on both sides. So my value of b is equal to -3 plus or minus 10. So my two solutions could be -3 plus 10, which is 7, or -3 minus 10, which is -13. The reason we have two different possibilities is because if you looked at this graph, this -3, +2 could be the same distance away for 7, +2, and -13, +2. All the way out here, be way back here. But they would have the same distance between, but there's two different possibilities for a distance of 10. All right, let's do the next one together because it's a little bit different. The points are 5, A, 9, 6, with a distance of 4 square roots of 2. Notice it kind of looks like our first answer. It's a simplified radical. So let's first put it in our formula. 4 square roots of 2 equals the square root of my x value subtracted, 9 minus 5, squared, plus my y value subtracted, 6 minus a squared. Now the reason I said this one was different is because we didn't have those values canceling each other out. This whole problem here, nothing so far. We could simplify this, and we will simplify it in just a moment. But in order to get rid of, we're trying to solve for a. The first thing in the way of a, besides the quantity squared with the -6, or 6 minus a, and this term, is this entire square root. So just like we did before, we are going to square both sides of the equation completely. Now this squared goes out to both of these. We have 4 squared and we have the square root of 2 squared. So 4 squared is 16. The square root of 2 squared gets rid of that radical, and we just get 2. And this equals the squared just cancels off the square roots. So I have 9 minus 5 squared plus 6 minus a squared. Now I'm going to simplify this. I have 16 times 2, which is 32. 9 minus 5 squared. Well, 9 minus 5 is 4. 4 squared is 16. Now I can't simplify that any further. Notice here, though, I've got this quantity squared. We did this with quadratics. We are trying to isolate this whole quantity squared. So the first thing I'm going to do is subtract 16. Now that I've gotten to this point, this is where we were at this point. We just didn't have an extra quantity to move over since it canceled off. So now that I've gotten to this point of the problem, it's just solving a quadratic. The inverse of squared is square roots. Since I am solving, I'm going to do plus or minus 4 for the square root of 16, and this will cancel the squared to leave 6 minus a. Next, I'm going to subtract 6 from both sides, and I have negative 6 plus or minus 4 equals negative a. And my last step to get a by itself is divide by negative 1. So I have negative 6 plus or minus 4 divided by negative 1 is equal to my value of a. Since these are all whole numbers or integers, I'm going to solve for my two values of a. I have negative 6 plus 4 divided by negative 1. So negative 6 plus 4 is negative 2. Divided by negative 1 is positive 2. And negative 6 minus 4, which is negative 10, divided by negative 1, gives me a value of 10. The reason, once again, that we have two solutions is because this ordered pair, 5, a, could be at 5, 2 or at 5, 10. Two different positions, and I've got a video in Canvas that you can watch if you need to see how those two positions are both on there the same distance of 4 square roots of 2. All right, the next problem, we're going to apply this to the real world. Kind of what this lesson's all about is the application. A student is taking the bus home. The student can get off at one of 2 stops, as shown on the map. The distance between consecutive grid lines is 0.5 of a mile. So you notice on here it is labeled to 0.5, so it is saying that it's 0.5 of a mile. We have the person who's home right here, and there's stop 1 and stop 2 for taking the bus home. It says find the distance between stop 1 and home rounds to the nearest hundredth. So I'm just going to put distance equals. Now when I find the distance between 2 points, I want to know what those 2 points are. So stop 1, the ordered pair is 0.5, 0.5. So 0.5, 0.5. And home, if you notice on the graph, is on 2.5, 1. Just finding the distance between those 2 points and rounding to the nearest hundredth, notice this time we are in the real world, so we are going to find that decimal amount. I'm going to put the square root of my x value subtracted first. 2.5 minus 0.5 squared plus my y values, 1 minus 0.5 squared. This simplifies to the square root of 2 squared plus 0.5 squared. Simplifying 2 squared and 0.5 squared, I get the square root of 4.25. And rounding to the nearest hundredth, I get 2.06 miles. All right, go ahead and pause the video to find the distance between stop 2 and home. Round to the nearest hundredth again, and then you can go ahead and answer part C for which distance is shorter and by how much. All right, check first that you have your ordered pairs correctly. Stop 2 is 1.5, 3, and once again, home is 2.51. So when I round to the nearest hundredth, I found that stop 2 to home was 2.24 miles. Well, clearly, answering part C, I know that stop 1 is definitely closer. They have less time to walk, or less distance to walk. So the distance is shorter, stop 1, and I subtracted those two distances to find that it was shorter by 0.18 of a mile. All right, flip it over to the back side. The next piece of application we're going to do is the midpoints. And we're going to use the midpoint formula, which is very simple. Midpoints of anything, if you're talking about the average of something or the middle, we've talked about things being directly in the middle. In this case, directly in the middle of these 2 points, A and B, is literally finding the average between those values. So as it already gives you over there, using those endpoints, our midpoint is equal to the values of the x's, x1 plus x2, and just finding the average between them, which means the y value of my midpoints, which would be our y values added together, y1 plus y2, also divided by 2. That is all we have to do to find the midpoint between two endpoints. So the first problem, for example, is -3, 7, and -1, 11. We are finding the midpoints of the line segments between the given endpoints. So I'm just going to put here my midpoint is equal to, and I'm going to first take my x values and add them together and divide by 2 to find the average. Please show your work. -3 plus -1 divided by 2. My y value will also be the average, but this time of the y values. 7 plus 11 divided by 2. So simplifying my midpoints, I see that I have -3 and -1, which is -4 over 2. 7 plus 11, which is 18 over 2. And this one comes out very nicely. My midpoint is -2, 9. So directly between the points -3, 7 and -1, 11 is the ordered pair -2, -9. All right, so hopefully it was easy enough. Here's your problem that you can pause and work on. I have -9, 5, and 7, -14. Pause the video and find the distance, or find the midpoints, I apologize. Okay, find the distance between these two, find the midpoint between these 2 points. I added together my x values and divided by 2, added together my y values and divided by 2 to get -2 over 2 and -9 over 2. Simplifying down to -1, -9 halves, or -1, 4.5, -4.5. Either one of these are fine since this is a terminating decimal. Okay, let's take the midpoints to a real-world situation. Sales. Use the midpoint formula to estimate the sales of a company in 2000. Given the sales in 1995 and 2005, assume that the sales follow a linear pattern. So here we have our first point. This is our x and this is our y. Our first point here in the year 1995 was $740,000, and I'm going to write that as an ordered pair. In 1995, the sales were $740,000. In the year 2005, the value was, in sales, $980,000. Now, if you really think about the midpoints, we are finding directly between 1995 and 2005. In this case, it's going to give us the year 2000. So that's what we are trying to estimate the sales in the year 2000. So all I have to do is find the midpoints. So my X values, adding them together and dividing by 2 would be 1995 plus 2005 divided by 2. And my Y values would be the sales, $740,000 plus $980,000, all divided by 2. So right here, 1995 plus 2005 divided by 2 gives me 2,000. 740,000 plus 980,000 divided by 2 gives me $860,000, which is great because we want to know the sales in the year 2000. So all we have to do is look at the Y value and we can find the sales were $860,000. All right, so you have a player kicking a soccer ball from a position that is 10 yards from a sideline and 5 yards from the goal line. The ball lands at a position that is 45 yards from the same goal line and 40 yards from the same sideline. How far was the ball kicked? Well, if that description was not a great description for you, you do have the graph over here. And if you can't see this because of the kind of dark quality, it is 10-5. And over here where the ball fell was 40-45. Go ahead and answer part A and part B. This puts together two things we have learned today, so make sure you see what the question is asking. Pause the video and try this problem out. The first question asked us, how far did you kick the ball? Well, if you know your position and you know the ball's position where it lands, the distance of how far you kick the ball, you can use the distance formula. So I knew I was trying to solve for the distance here. I plugged those two order pairs into my distance formula. I simplified and I solved to find that you kicked the ball 50 yards. Make sure you have units on that, and this one came out completely perfect, so make sure it is simplified to 50. The second question says, suppose someone on the other team intercepted the ball with a header halfway to your teammates. At what position was the opposing player? Well, if they were halfway from that distance that you kicked the ball, that's going to be finding the midpoints. So I plugged my values in using the midpoint formula that we just did, finding the average between those 2 points, which I ended up solving out to 25, 25. And I went ahead and interpreted it just like the word problem said. Since X and Y, so X was the goal line and Y was the sideline, I knew it was 25 and 25, so if you have these flipped, it doesn't matter which one you stated first. 25 yards from the sideline and 25 yards from the goal line. So here, hopefully, was easy finding the distance and the midpoint for both parts. The next thing that you are going to be working on is a partner project. You are going to be finding various times midpoints and distance. So please use your notes. If you need to search other videos that I have in Canvas, feel free to do other videos on there. But you are working on that project, your midpoint and distance project, with your partner that you are sitting next to. If you do not have a partner sitting right next to you, you may find another partner someone does not have a partner, or you may work in a group of 3. Please do not go moving around the room trying to find someone else to work with if you already have a partner for this activity. Make sure you're ready to check homework tomorrow. Thanks.